Let's move now to European Network Codes, a first step towards flexibility, by Daniel Daví. Daniel Daví is an electrical engineer. He has a bachelor degree in economics and a master in economics. He's working in Endesa since 2000 and has occupied several positions in the distribution business line. Nowadays, he's a member of the committee devoted to the discussion and implementation of the European Network Codes in Spain.
Good morning. I'm Daniel Daví from Endesa. It's a pleasure for me to be here explaining this presentation. In my case, I won't explain any project. My presentation will be most devoted to explain the real life. I will put your feet on the ground, and I will go a step back, because I will explain how Europe is considering flexibility in the regulation. And I will explain that through the European Network Codes. So this is the outline of my presentation. First of all, I will define European Network Codes, because some of you perhaps do not know a lot about that. I will explain electricity systems, how have they evolved, and I will explain flexibility. I will say some definitions, and I will comment how four network codes try to regulate flexibility. And finally, I will explain the following steps considering the DCO point of view. So, what's a European Network Code? It's a new technical rule to the energy sector, which tries to define some technical issues. They are binding in all member states, and they are adopted and approved by the European Parliament. We have three main groups of connection of network codes. We have connection codes that try to define conditions and capabilities of the new generation and demand that must be connected to the grid. We have operational codes which try to define how to manage and how to operate the previous capabilities we have defined in the connection codes. And finally, we have market codes that try to explain and to define how to integrate markets and increase competition, especially considering transborder effects. Why are they important? Because they try to define harmonizing how grids operate across Europe and defining a close coordinator. The idea is try to make the best use of the power network. This is not just a fact of cost, it's just a fact of security of supply, because if our system is coordinated among Europe, the idea is that it will improve, it will perform better and more efficiently than if not. So network codes, we have three main groups I have explained before. Regarding the connection code, we have a code for the demand connection, requirement for generation, and a high voltage direct current. These three codes are approved by the European Parliament, and here in the red star I have highlighted which ones consider flexibility and the ones I will explain you later. The other group is the system operation grid codes. They are in blue because they are awaiting the validation of the European Parliament. We have a system operation and the energy and restoration. And we have another main group regarding the market and trading codes, which we have the capacity allocation, the forward capacity allocation, and the electricity balancing. So, my colleagues have also explained that, but I think it's important to know, to be aware about that, because how our electricity system have evolved along the time. Here we can see in the past, we can think before Red Eléctrica was in Spain, or we had the TCOs 40 years ago, we had just a single system operation, try to coordinate and to have in a balance the transmission and the system. In the present, in the middle, we have an unbundling of activities. We have a transmission system operator and a DCO. Here we have, you can see the wind farms, you have a PV panel. And in the future, which is the last picture, you have storage in the transmission, storage in the distribution. You have more amount of capacity of distributed generation. And I think that the more relevant of this picture is the blue line, which shows you the communication flows. So the system becomes more complicated, more complex, and there's an amount of interconnections, and when you will have a more difficult system to manage. Using the previous slide, here I've written how decisions are taken in the market. 40 years ago, random weather conditions just were used to forecast the demand. Here, I'm thinking in a system without smart metering, so you have the same price. You pay the same price for energy independently where you are consuming. We have to forecast, we have demand as a given, so we have to match with the generation. And at the end, we have a final match of demand and generation. In this scheme, flexibility was mainly provided by generation, by conventional generation, which is the technology that can provide this flexibility. Now, this is how the future will be. Let's think in a clean mix. Random weather conditions will affect both sides, not only on the demand, but also in the generation. On the demand, we will have another fact, which is the self-consumption. If we have a sunny day, it affects the demand that we will have tomorrow. And rather weather conditions also affect the generation, because if we have a windy day or we have a sunny day, it directly affects the supply of energy. In the final match of electricity, now the flexibility will also be provided not only with the demand, but also by the small demand consumers. I'm thinking in aggregators. This is what I have explained. In the past, the flexibility was almost required by the TCO, and the TCO was passive. And in the future, we will have active DCOs, and new agents will be able to provide flexibility. I'm thinking in small generation plants, domestic consumers, by aggregators, small storage devices, batteries, vehicle to grid. So here there will be a lot of agents. And the cheapest one will be who will provide flexibility, not just only by the generation. So using what I have explained, flexibility could be defined as a modification of generation or consumption in an individual or aggregated level in reaction to an external signal. Here we can think in a price, in a tariff, in a way to solve a technical congestion, in order to provide a service with the energy system or maintain stable grid operation. Maintain stable grid operation, just especially for the transmission system operator. So now I will explain you how these 4 grid codes are already considering the flexibility, and you will see how Europe has put some steps to try to define that. The idea of the demand connection code is to define rules, common rules among Europe. And in this code, there's defined demand response services in 2 main groups. On one side, we have remotely controlled demand response, which is the active power, the reactive power, and the demand response to solve constraints on the transmission. And we have also the autonomously controlled demand response, which tries to stabilize the system and try to control the frequency of the system. The last group are important because when we are introducing more renewable technology, they perform different than the traditional synchronous generation. So the frequency, the inertia of the system performs better. And this grid code recognizes the aggregators that then can provide demand response. So this code defines that. Now in Spain, we have the door to regulate that. The other code, this code defines requirements for new generation that will be connected in Spain or in Europe. The idea to define common rules is try to define the same requirements for a wind farm connected in France than in Spain than in Italy. And the idea is if I have common rules, the flexibility requirements will be slower. Some issues that are regulated here are the voltage control requirements. So here, in the case of Spain, we have opened the door to develop a new market, which is the voltage control market, and we have defined, which will be one of the, not many countries in Europe will have defined that. We will require that PV panels at night, inverters, will be able to inject and consume reactive. The idea is that we have a lot of assets connected in the grids. We have small generation plants, and we can use these inverters to control the voltage. Because if the flows suddenly change in the grids, because we have distributed generation, so we think this capability will allow us to control the voltage and to have a quality supply for our consumers. Another requirement that is defined here is the information exchange between the system operator, TCO and DCOs, and the power generating facility owners. Here, if we want to know, as a DCO, to require flexibility, we should know in advance if we have a problem, how our grid is performing, if we have a voltage problem, if we have a congestion. So the idea is that almost all new generation plant will send information to the system operation. Apart from that, the capability to disconnect will be compulsory for new generation plants. So these codes are entered into force. Now there are two codes that are more focused on the TCO point of view, and they are awaiting the validation of the European Parliament. The first one is the electricity balancing guideline, and this tries to define operational and market rules, try to balance the markets, and it defines principles to procure frequency containment reserves. Here I explain frequency reserves. My colleagues have talked about that. The other one is the system operation guideline, which tries to define how to operate the requirements I have explained before for the generation and the consumption. These requirements are applicable to new demand, new power generation models, and to the demand facilities that want to provide flexibility. Here, the idea is to try to maintain the security of supply, have a coordination with the data information, and try to establish common rules about load frequency, control, and reserves. So, as you see, the idea is we will have a more difficult electricity system to manage, so we have to define rules. So, which will be the following steps, especially for the DCO? The DCO will be where most new actors will be connected, and I'm thinking, my colleagues have explained, in distributed generation, demand response, storage, self-consumption, and electric vehicle. So flexibility is a new aspect and a more active way in which we need to manage that. So why is it important? Let's think, for instance, that we have, in each case, in each picture, you will have a lot of people, perhaps a computer, taking their own decisions. So perhaps one decision of one, if everybody is connecting, is charging the electric vehicle at the same time, we will have a problem of congestion. So a small number of people taking their own decisions, it implies we should define flexibility because we can have a problem. And it's a great deal for the DCO. Now the following steps regarding regulatory framework. We think that flexibility is the way to develop this, to get this deal. But we need, first of all, to allow the DCO become an active system operator. We want to invest in the grids. We need adequate capital investment return. The national legislation should create market flexibility mechanism and local flexibility markets, because if we don't create these markets, we won't be able to require this flexibility. There will be allowing the installation of storage devices, the aggregators should be defined, and the tariff schemes and incentives should be also updated. So, but which is the real life we have today, that at the moment